Okay. Hello, everybody. I'm Gabriel Urbain from the University of Ghent. And I'm a PhD student since almost 2 years now, I guess. And we entered a new phase in my project since January that I entitled the Bioinspired quadrupeds from simulation to walking robots. I will try in a few minutes to just emphasize the word bio-inspired and then what I mean like from simulation to hardware. So Bioinspired, basically it has two components, the controller and the body. For the controller, it just means like using sparking neural networks on neuromorphic hardware. But also we think that the body is really like important in the case of morphological computation and embodiment. It influences the way you can drive the old stuff in closed loop. So we also use deformable parts and compliant spring and so on in our robots. So basically it's like a bottom-up development process with a lot of iteration with laser cutting and 3D printed robot, cheap, small, and not the one you see in Boston Dynamics. So in classical robotics generally, when you want to control a robot, what you do is that you know the model, you invert it, and so from a trajectory, you can find the torques. It's kind of more difficult when you have deformable parts. So machine learning is really well suited here, like evolutionary algorithm or reinforcement learning, for example. But it needs a lot of iteration. So we have to do that in simulation because doing that on the real hardware is really difficult, which brings a new problem on transferring the knowledge between simulation and the robot. And for that, we tried something, I think, kind of new. We didn't find anyone doing that. If you know some, just tell me, I'm really interested. Like adding some noise on the morphology itself. And like the last part, but I won't go too far on that, it's just implementing the CPGs to control the robot using a liquid state machine on Spinnaker and linking that to the robot. Thank you.